Welcome back, ladies and gentlemen, to the Learn to Code segment of the Devslopes Game Academy. And today, we're going to talk about functions. And functions are a way of modularizing your code into areas where you can have actions take place. Things that can manipulate variables or call other functions. And it's a great way to break out your programs, and they are a foundational building block of any program in any programming language. So what we're going to do is we're going to create a new script here. Create C# script, and we're going to call it uptown function you up. Why not? Okay. Double click it to open it here. Okay, you've already seen functions, right? You've seen two here over and over and over again. Void start, void update. Now a function can return something or it can not return something. It has a name, and it can have one or more what's called parameters, or sometimes known as arguments. And then it has code in here. So the start function is a built-in function from Unity, from this monobehavior class that is called when the game starts, or when the object comes to life, rather, okay, in your scene. The update function is called a bunch of times, X amount of times a second, 60 frames a second or 60 calls per second, whatever it may be. It's different depending on the hardware that's running it, and it calls it over and over and over again. And this is a looping function, and Unity manages all that under the hood for you. But you can, of course, create your very own functions and classes. So let's go ahead and do that now. Let's pretend we have a game, and it is a game, a battle arena game where you're going to fight to the death. And so a player will have something called health. So int health equals 100, and it might also have an attack power. So attack power equals, let's say, 25. All right, so health, attack power, those are two variables that this player has. And let's say in our game we want to have a button, and whenever we click the button, it's going to take damage away from the player. Okay, well, how do we do that? How do we get our button? Well, our button wouldn't call the start function or the update function. That just doesn't make sense. So let's even get rid of these. We don't need those to be there. Let's create our very own function, and let's handle the very first event, which is called attack. So what we're going to do is we're going to say void attack. Okay, and what's going on here? Well, void means we're not going to return anything. Okay, this function will not return anything at all, and we'll show you how it does return something in a minute here. The name of the function is attack. Did it have to be a capital A? No, it could have been lowercase a. In Unity, they usually have all their functions with an uppercase. Some C# developers don't do uppercase. Some of them do, camel casing like that. But we're just going to leave it all uppercase to keep things consistent here. And this function currently has no parameters here inside the parentheses. Okay. So what we want to do is we want to attack the player. Okay. So what we're going to do is inside of here, we're going to say health equals health minus attack power. So whenever this attack, that's not what we wanted. Come on, attack power. Whenever this attack function is called, okay, it's going to perform an operation. It's going to take the current health and subtract the attack power from the health, and then it's going to store it back into health. Okay. It could also have been done like so. Health minus equal attack power. That's the same thing. Okay, same thing. Health equals health minus attack power. What it does is this one right here takes health, subtracts health, attack power from it, and then puts it back into health. That's all that's happening here. So that's what's happening on this attack function. Okay, a function can also be public or private, and you'll learn more about that when you're working with classes. But private means that other classes, like this list time baby or conditionals.cs, cannot access this function here. Public means it's publicly available for other classes to access. And in this case, we of course do want other classes to be able to access the attack function because we want to be able to attack the player. Okay, and then let's just do a debug.log, and we're going to say health after attack is equal to, and we're just going to say health. Okay, we're taking this string and concatenating it with this variable. It's taking this variable and converting it to a string. Okay, and you know what? Let's put the start function back, and we'll go ahead and print up the current health at the beginning of the start function as well. So there's a debug.log. We could also be using print statements, by the way. I'm just interchanging them. Debug.log, and we're going to say health at start plus health. Okay, so currently right now, nothing is calling this function attack. Nothing at all. If we wanted to call the attack function, we could do it from here, from the start. Okay, you call a function by saying the function name. You don't put the public or the void in front of it. You just call the function name and the parentheses after it and then a semicolon. But we don't want to call it from start. That doesn't make sense. We actually have a game here, right? So let's go back to Unity. Save this file. Go back to Unity. And what we want to do is just create a simple button. So I'm going to right click on the hierarchy over here and go to UI, and I'm going to tap button. You'll see a button has appeared here on the middle of the screen, which is great. And it's a little bit small, but it's okay. It doesn't really matter right now. And what I want to do is I want to get this button to call the function whenever it's clicked, okay? It has a text field on it as well too, which we can change. I'm going to change it from button to attack. Okay? And yeah, this all looks good. Looks good. All right, so what I want to do is on this button here, where it says on click, I want to click the plus sign. And what we're going to do is we're going to drag in our main camera here that has the uptown function you up script on it. But we haven't put that script on it yet. So let's do that now. Take this uptown function you up script, put it on the main camera. Okay. And then on the main camera, let's take off our old script if you have it on there still from the list time baby. I'm going to remove that. Okay. Go back to my button. Okay, so now what I'm going to do is I'm going to take the main camera, drag it onto the slot here, and then where it says no function, I'm going to pick uptown function you up, attack. Now if we didn't make this function public, it wouldn't be appearing here. Okay, so we're going to click the attack function. This is our function. Okay, so whenever that button's clicked, it's going to go into our code and it's going to call this function. Now let me specify, so you're not confused, that the Unity button and that on-click attack, the on-click thing that calls your attack, that is not part of C#. Okay, that is a Unity thing, and it's going to call our function for us. So if you're thinking, oh, that programming works like that, no, it doesn't work like that. Every program works differently depending on what interface it is. But what is consistent from Unity and across all platforms working with C# is that we're creating a function here, and we're going to call it. So that on-click function that's on the Unity user interface is doing the equivalent of this. Okay, it's calling this attack function. It's just doing it at runtime. So when I click that button, when the game's running, I should see this print out every single time. Okay? So let's go ahead and play. Okay, it's playing. Click attack. Okay, if you look at the bottom of the screen there, it says health after attack 75, 50, 25, 0, 25. Oh, cool. I know what some of you are doing. You're like, oh, I know how to make buttons now. I got all kinds of game ideas. If you do, just go with it. Roll with it right now. Go throw some buttons on and have some fun. So what we've done here is we've called our function. It's performed an operation, and then we've printed out what it was supposed to do. I think that is pretty cool. Okay, so that's in the game we attack somebody. Now let's say our player, okay, our player just went over a mystery box, okay, and it's a mystery health box, and it can restore some of your life, but you don't know how much it's going to restore. It could be a little bit, it could be a lot. So let's create another function that can do that. Okay, so we're going to create another function here called public void heal. Okay, and what we want to do is we want to give some health back to the player, but we want it to be more randomized. So I'm going to create another function, but this one's going to be private. Okay, and this one's actually going to return an integer. So instead of saying void means don't return anything. We're actually going to return an integer, and we're going to call this get random number. Okay, and what we're going to do here is we're going to use a return statement. Okay, return is going to return something back to the user. So or back to the function that called it, excuse me. So we're going to return random.range. This is a Unity function that'll give us a random number. So we're going to get random.range between 2, and I'm just putting an arbitrary number, and let's say 10. Okay? Now, something very important to know is random.range in Unity is inclusive. So it will be 2 and in between 2. So you'll be able to get numbers between 2, 3, 4, 5, 6, 7, 8, 9, 10. Whereas there's other types of functions for random ranges that are exclusive, which would be between 3 and 9. Okay, just know that these are inclusive, and that's in the Unity documentation if you have any question about it. So what's happening here is we've got a function. We're saying this function is going to return an integer. Okay, random.range happens to return an integer. I also could have just said 15, and it would work. But watch what happens if I say a string, yo. Okay, if I go to my Unity, it should be yelling at me. See, cannot implicitly convert type string to int there at the bottom. Okay, it's not going to work. You can only return the type that you said you're going to return. Okay, there we go. All right, so that's a private function. So we don't need the buttons to access this. This is something internal to our code here, to our class. But the hill function should be a button. Okay, and so what we're going to do here is we're going to say health, instead of minus equals this time, plus equals get random number. Pretty cool, huh? Interesting. So what's going on here? So the attack function, that's being called by the button, and it does its thing. The heal function, it's going to do something similar, but the heal function is calling another function. It's calling our get random number. So what's happening here is when we call this line of code here, it's moving down here, okay? Okay, and so it calls this function, and then what it's doing is it's returning a random range. So the random.range is going to give us an integer. It's going to create a number, and we return it. And when that return keyword happens, this is what's happening. It's like shoving it all the way back over here. Okay, so whenever you call a function, just pretend this function call is being swapped out by whatever gets returned here. Okay, so we return this, and it goes back over here. So instead of get random number, this is a number between 2 and 10, and it adds it to the health. Okay, and then after the health, we can say debug.log. Okay, in fact, what we probably should do is, if we want to get really cool with our logging, put that in a variable. So we say int added, or we'll just say heal amount equals get random number, and then health plus equals heal amount. Okay, that way we can actually print both. We can say debug.log received. There we go. And let's add a plus sign here, and we're going to say heal amount, and we're going to say plus health. So received X amount of health, and then we can say debug.log you now have, and this time we're going to say health, which is the full amount, you now have plus health. Okay, so let's get that a shot. See if it works. Go to Unity. We're going to go to the canvas here. We're going to create UI button. Okay, let's call this one heal. Let's call this one attack. Attack. It's Logitech keyboard. After using it for like a few hours, it just stops typing, which I have to switch to my mechanical keyboard. Big huge pain. Logitech just is the worst. Okay, heal, and what we want to do is we just want to move it somewhere else. So click the inspector and just move it over somewhere, like so. I'm just dragging on the X position. We could have done it on the Y. I could have done it in a positive number 2, as you can see here. Okay, and instead of button, I want it to say heal. Okay, and then what I want to do is on this button heal, scroll down where it says on click, click the plus sign, drag the camera over again. This time we're going to choose from uptown function you up, we're going to choose hill. Okay, and let's see if I can scale all this up here so you can see it a little bit better. A little fuzzy, I'm just zooming in, that's all. So alright, so if I attack, oh no, I'm losing life, down to 50. Now if I click heal, you now have 58 health. And if we look at our console, it actually told us before. We received 8 health, we now have 58 health. Do it again. we receive 3 health. You now have 61 health. So it's cool. It's definitely random, and it's definitely working. Look at it go up. Bring, bring, bring. Haha, take that. Oh no, I'm being attacked again. Pretty cool, right? So what you've done so far is you've worked some simple functions. You've returned something. You've created a random range, a number generator that comes in over here, and then you've called these 2 public functions that are available to outside world, such as the Unity editor or the Unity UI system, so that they can actually call it when a button is pressed. Really cool stuff. Not that many lines of code too, right? There's one more thing I want to call or talk to you about with functions, and that's parameters. So let's say that this attack function, it's great for attacking, but I feel like this attack power is not enough. What if the player has a shield? Okay. Oh yeah, that's important to know, right? So maybe the player does have a shield, and the shield is equal to, let's just say, actually let's make it a boolean. So bool shield on. You know, shields up. You know, like in Star Trek. You know, when they always turn on the shields like right before they're about to be blown up, instead of doing it like 20 minutes ago before the blasts even came. Shields on equals true. So this player has a shield on. Okay. And what we can do is, yeah. How about shield on and shield amount? Ooh. Shield amount equals, let's say, 15. So rather than just saying attack power, okay, let's create a new function, private, and we're going to say int, and we're going to say get attack damage. Okay, so it's not enough just to use the attack power. We have some other factors we need to consider, and I don't want to write it all here in this attack function. I want to break it up more, modularize it a little bit more. The more you modularize your code and your functions, the more reusable they become. The more code that you write in a single function that does different things, the less you can reuse it, because other classes can't use it because there's so much going on in it. But if you break things up into little pieces, it becomes more reusable. Like this get random number. What if I always wanted to be able to get a random range between 2 and 10? Well, if I had just plopped this in the heal function, other classes that need the random range, maybe for damage or things like that, wouldn't be able to use it. That's why we separated it here. So get attack damage. How should we calculate the attack damage? Well, maybe we should basically see if the shield's on, and if it is on, we do some type of multiplier that first takes from the shield and then takes the rest from the player. So what we can do is we can create a parameter here. All right, we can say bool is shield on, and then we can say int the shield amount. I'm going to say AMT. Okay, and then we can say int the attack power. So what are we doing here? We've just created 3 parameters, okay? We've created 3 variables within our function. And what happens is when you call a function that has parameters, you pass data into these slots like little buckets, and you're giving a name to these buckets, and then your function can use them. So basically kind of copies the data into them and renames them to whatever we've passed into them here, okay? So get attack damage, great. So what do we want to do? Well, let's just figure out some math here. It doesn't really matter what it is. So if is shield on, so if that's true, then what we want to do is we want to set some type of attack damage. So we're going to say int, I'm going to say damage. Let's start it off at 0. Okay, so if the shield is on, what we're going to do is we're going to take the attack power minus let's say 10% of the shield power. Okay, so if the shield is on, we're going to say damage equals, we're going to say the attack power minus, and we're going to say the shield amount times, we're going to say 10%. In fact, we don't even need these outer parentheses here. Cool. The shield amount, damage. Now, we're going to need to cast this to an integer, like so. Oops, I think I wrote this wrong here. Oh yeah, I'm writing Swift code here. Woo! What we want to do is cast this as an int. There we go. Because if we take a float and multiply it, if we take a float and multiply it by an integer, it's going to give us a float here. And we want to cast that back into an int. Let me make sure our code's good. It's not yelling at us in the compiler here. Non-nullable value type. Yeah, I did it wrong. Double click it there. Let's see if it works without it. Okay, so this is what I was expecting. You cannot convert a type float to int, okay? So we just need to cast it the proper way. Oh, you know, I think I forgot my parentheses is what it was. Let's do this. Let's cast this as a float. So it does the math, and then what we'll do is we'll cast it back to an integer. I think that is our problem. Yeah, let's change this back to an int. Oops. Okay, so we're going to cast this to a float. Yeah, and we'll put this in parentheses. So this is already a float. Cast this to a float because it's currently an integer. And then when the operation's done, we turn it back into an int, which drops the trailing decimal on it. And that's what and then we take that away from the attack power. And that's our actual damage. Let's see if it stopped yelling at us by now. Okay, perfect. Not all code, yeah. And so it's yelling at us because we haven't returned something yet. So we're good. So if you don't understand what's going on here, we just set a variable here for damage. And if the shield is on, we want to do some special math, which is we take the attack power, this one right here. Okay, and what we're going to do is we're going to take the current shield amount that gets passed in here, and we want 10% of it. Okay, so we're going to take 10% of that shield power, and that's going to be subtracted from the total attack power. So our attack power is not as strong because we have a shield. And what we're doing here is we're casting the shield amount to a float that's currently an integer, and you can't multiply an integer times a float here. So we turn this into a float, we multiply the float, okay, and then when we get that operation done, we turn it back into an integer right here, so it can be subtracted from the attack power. Does that make sense? If not, just look at the code very carefully until you understand. Don't move on until you understand every line of code that we're writing, okay? It's critical that you understand every line of code. A lot of people like to move on. They're like, oh, I'll figure it out later, or they kind of get it. No, you need to all the way get it. Otherwise, things get more confusing. Cool, so now all we need to do is return damage, right? But what if the shield isn't on? Well, then we can say else, and we'll just say damage is equal to the attack power. Just the original attack power if there's no shield. Pretty cool. Get attack damage. I like it a lot. But how do we actually call this function? We're passing in 3 things. It's returning something. Well, up here, okay, instead of doing health minus equals attack power, what we should do is we could say int damage, we'll just say damage to inflict equals, let's call get attack damage. And notice how it's asking for 3 parameters there in the little helper pop-up. Is shield on? Well, is the shield on? It is. So let's pass in that first variable, shield on, up there at the top. Okay, the second one, it wants the total shield amount. Well, we have it up there as well too, shield AMT. Notice how these variables are spelled differently than these ones here. They didn't have to be, but I'm showing you for demonstration purposes. So you can name these variables whatever you want, okay? And if they were named the exact same thing, when you're referencing those names in here, it would refer to these ones down here, not these ones up here. This is called scope. You have local scope here. So let me just show you. If I actually change this to is shield on to shield on, the same as this one, okay? When I'm inside of here and I call this shield on, it's going to refer to this one right here and not to this one, even though they have the same name. This isn't the global scope, but local scope always overrides the global scope. And it may take some time to understand that, but just so you know. And then the third parameter is the attack power. Okay, so that's attack power. Okay, so damage to inflict equals get attack damage. We pass in if the shields are on, the shield amount, and the attack power. So it goes down here. It drops in the boolean here, so it goes and finds this one, shield amount, it plops it in here, gives it a new name, is shield on, and of course it's true. And then we do the same thing here with shield amount, the shield amount. In fact, that should be AMT instead of 2 M's. Oops. There we go. And so we go over here and we take this shield amount and we drop it in here, give it a new name called the shield amount, and then the attack power. It grabs the one from up here, 25, copies it in and gives it a new name. Okay, that's how parameters work. And then it goes through here, it does some math to see if the shield is on, and then what it does is it returns the damage. So this call right here, this statement, is going to go all the way back up to here. Just pretend that this is being replaced now and it's getting shoved into this variable. So this will be called first, then this, then it comes down here. It hasn't even got here yet. Okay, it's down here still, and then once it hits the return statement and comes back into here, puts in that variable, then it moves on to the next one. And so instead of just doing attack power, okay, we should say damage to inflict. Now, let's look at the math here, see what it's actually going to be. So attack power is 25. So, and the shield amount is 15. So what's 15 times 10%? So we're going to say 15, I just did command space on the Mac here, 15 times 0.10 is 1.5. Now we know since we're casting it to an int again, it's going to drop the 5 on there, okay? So our shields are 15, we're only taking 10% of it, so it's only going to take 1 damage off. So it's only protecting us by 1. I know the game's kind of lame, it's not very much, but so what we should expect to have happen is 25 minus 1, 24. So we should see 24 damage go every time we attack, if it's all working as we expected it to. Let's clear it out, play the game. Okay, so instead of being 75, we should see this at, what, 76 if I click attack? 76. Take away another 24. Okay, it's definitely working. Okay, the health is still working. This is working. Great. Cool, so we've learned a lot here. We've learned about functions. We've learned how to create a public function, which is available to outside classes and like the Unity UI system. We've talked about private functions, which are only accessible within this class. Okay, and to show you what I mean, if I went back over here to Unity, this get attack damage function, and I click heal, okay, go to my inspector, and instead of calling uptown functio-up.heal, okay, I want it to go to the attack damage one. It's not here. Get attack damage is not available. Why? It's because we made it private. Okay. And then we talked about parameters, also known as arguments, where you pass data into them. They kind of get a new name. The data gets copied over if it's one of the default data types like integers and strings and things like that. If you're doing things like game objects, if you're passing a game object in here like this, game object, okay, it's not copying it over. Programming doesn't work like that. It actually sends a reference to that same object, okay? That's a discussion for a later day, but just know that default data types like integers and things like that, they're copied in. Things that are classes or objects, like game objects and stuff with Unity, they are not copied in every case. So they're direct references to that spot in memory. Again, don't worry about it. You'll learn it over time. It's a more complex topic. And cool. Talk about parameters, functions. Functions are also known in some programming languages as methods. Okay, so in fact, to be honest, because I've been in so many programming languages the last few weeks, C#, I wonder if C# are called functions or methods. I can't remember. Sure enough, they are. I've been calling them functions, but in C# they're called methods. But same exact thing, functions and methods. Languages use them interchangeably. They're called methods in C#. Okay, really cool stuff. Really cool stuff going on here. And by the way, all these things you're learning, they apply to other programming languages. So, you know, when you learn about functions and parameters and stuff, you're actually getting ahead in the game on Swift, on Java, on other things you might do like Python. They're all very similar, and it gets you ahead of the game here. So what better way to learn than by making video games? But that's it for now. This is Mark Price with Devslopes.com, and we've learned about functions. See you next time.